yourself.
Sure. Hey, everyone. I'm Steve Schlafman. I'm a principal at Lair Ventures here in town. We're a seed stage fund. We've been looking a lot at the industrial internet as well as the Internet of Things, both on the enterprise side and on the consumer side. We're investors in MakerBot along with First Round Capital and then other things. Smart Things, and then also things like MakerBot. So it's an area that we're definitely very excited about.
I'm Finn Barnes. I'm a partner with First Round Capital here in New York, and we're investors in Smart Things. At First Round, we've sort of seen, we were inspired to start the fund based on the cost of starting a software company dropping dramatically. And now we're starting to see that in the hardware space and sort of in the services layer that sits on top of what cheaper hardware companies enable, sort of the services layer. And so we're very excited to sort of see where the whole space goes as clumsier and clumsier hands can manipulate larger and larger things. I think it's a really interesting time and space to be investing.
Great. And you also have the nicest collection of sneakers of any VC.
Yes, I work very hard at that. These are I can expense them now. It's become a branding thing. So.
Very good. All right, so I think Alex started. This is so right and so wrong at the same time. Alex started talking about this during his presentation. So the concept of Internet of Things is not new. I believe somebody came up with the term in 1999. So it's been a while. So what's different? Why are we now reaching a little bit of a tipping point where things seems to be accelerating? Anyone?
I mean, lots of standards so that you can now connect a device for $2 to $5 and have a range of 1,000 feet and battery life of 2 years, checking in every 5 seconds. So insane applications come from these very low bar for the technology to connect something. Cloud computing, a lot of this other emergent stuff. I talked about the smartphone revolution. All these things sum up together democratized hardware with 3D printing and prototyping and circuit manufacturing. If you read the Time article this week on manufacturing jobs coming back, it's really robots coming to the U.S. To manufacture stuff. But all those sum together to sort of create this acceleration moment where you have the ability to connect something, have it connected to the cloud. There's proxies for developer platforms like app stores, so there's developers ready to build these bite-sized pieces of software, and sort of on and on and on. Like it's all those layers, just the sort of right flashpoint.
Yeah, and then there's also a few macro trends that we're seeing with crowdfunding. Historically, getting hardware companies funded was very difficult, and this allows companies to essentially prove their concept with an initial audience, which is really key. Also, the democratization of design tools, historically very expensive for individual makers to purchase unless they get them pirated. But these tools are becoming cheaper and cheaper and more accessible.
I mean, I think just generally there's a parallel in the software space. So there's a model to sort of look at to say this is how large companies were built in software, either as platforms or on top of platforms. And so now you're just opening up more tools to those same minds and those same entrepreneurs.
Right, and the cheapness also means that you don't have to be good anymore. I mean, at least at the outset, right? Yes, it's so easy. You can literally buy the parts at Radio Shack to get started on some of this stuff, and it costs like in the single-digit dollars to have a substantial amount of computing power from Amazon, and then that's all you need. And so it's not like you don't have to be as good as Bill Gates was when he built the basic interpreter in something like 16K of memory. Your software can suck and be bloated, and it still costs nothing to run it. Same with the hardware. It has to get good eventually, but first the barriers to entry are very low.
Great. So we, a lot of us here are focused on the startup world. So where do you see opportunities? I think Finn, you started mentioning platform. Is that at the platform level? Is that at the application level? Is that at sort of the connected tissue that needs to be built? What are the building blocks that need to be built? And the related question is, how much of a startup opportunity is that? Companies like GE or IBM or a lot of those car manufacturers seem to be already very active in the space. Is that going to be a game that's going to be won by startups or by those large companies?
Well, my feeling is that one of my favorite sayings is that Steve Jobs did not invent Angry Birds. In fact, if you go back in history on Apple, they didn't invent VisiCalc either, which is the reason that Apple even got to where it got for the Apple II. And so my feeling is that the cool new killer apps are not going to come from GE or Cisco or IBM. They're going to come from like folks who are in this room. And I just think historically it's been proven. It doesn't mean that you're not going to see a lot of cool stuff happening. My feeling, we're talking a lot about entrepreneurial things going on in the consumer space. I actually think there's a lot of interesting things happening in the enterprise space. And the nice thing about the Internet of Things and the enterprise is that these are companies who are willing to spend a lot of money to get some of these benefits. I mentioned the office, furniture maker. There's thousands of companies who are in that same position who are trying to take devices and get them sort of onto the Internet of Things and find new ways to find value. And so these are companies. If you're an entrepreneur trying to start a company, there's one thing is to go after a consumer space, which means you probably have to go and raise a lot of venture capital. But going after the enterprise, the benefit is you can actually sell things for real dollars and maybe not have to go and raise a lot of money off the gate. And that's one of the things that we've found. So don't ignore that as a possibility for an audience.
It's going to be an ecosystem. I mean, is a broad term, but it's just a huge opportunity for a lot of people. So I sort of think of it in different buckets, if this would be helpful to lay out over sort of 30 seconds. One is wiring up the world. So there's a compelling reason to connect stuff because you can sort of make it more intelligent and sort of change security or convenience or energy use and things like that. And so there's going to be people that make stuff, and then there's going to be people that sell the stuff to people to sort of put it in their lives. So there's an enormous opportunity and sort of innovation changeover there. What's going to cause you to get the new office chair? Well, both the app plus the Bounce app, which is going to wear it out faster. But so wiring up the world. There's an enormous, we think of it as apps and services opportunity. And so we have this sort of free apps and services within our sort of equivalent of the App Store. But we see a lot of people building connected paid apps and services. So I'll take an example of energy. We have 30 developers building learning algorithmic thermostat management apps that use any off-the-shelf thermostat, right? And cost $4.99 or something in there. Or for security, my favorite example is sort of an Uber of off-duty cops. It's just a better model than the ADT India call center, right? You're going away on vacation, and I install this service for smart security, 3 blocks from my house, and somebody with a badge and a gun shows up when they need to or whatever. So apps and services. And then there's an enormous sort of big data opportunity, just generalized. I think there's advertising opportunities. There's, given the form of we know when a device comes online, when it's going to sort of malfunction, and sort of the impressions you can make around sort of the collection of all this data. And it's a very, very, very big, nut that we could talk about endlessly. But those are how I think of the 3 sort of giant buckets of opportunity.
I think there are areas where big companies and startups are going to find themselves competing, but there are also a lot of areas where they just won't be at all, and there will be a much more nuanced relationship between the two. There's a reason that jet engines are built by GE and not us as hobbyists, and so I think GE will still build the jet engines and Ford will still build the cars, but then there will be a process of negotiation where it's decided who gets to build the platforms that link all of these things together. GE and Ford have decided that they want to sort of preempt other platforms that might come along by releasing their own or releasing something like a platform, even if it's not open to the public, and that's an effort at preventing Android for jet engines from coming along and just completely wiping out all of the software advantages that these companies are trying to build up for themselves. So I think there will be developers will have a lot to get out of building stuff on Ford's platform and Philips's platform and Siemens' platform and so forth, but it'll be a complicated negotiating process.
One other comment is we see a generalized sort of massive fork in the road. It's not really a fork because both forks will be explored simultaneously in sort of a quantum way, but sort of open versus closed on this physical graph. And we're choosing this open path. You see these compelling reasons to sort of open up the data that are really unexpected. So the accelerometer tied to the office chair has unexpected applications. The sleep sensor guy that makes a sleep sensor that never talk to the coffee pot guy, but together they can make the coffee pot that turns on 30 minutes before you wake up. These sort of magical opportunities, not to sort of trivialize it, but there's some really big ones that kind of come as a sum of all this stuff connecting in a way that you don't necessarily expect. And so there's enough reasons to sort of have an open, connected platform, in our view, that it will drive to be commercially successful. So it'll sort of certainly be there alongside some of these closed efforts, and I think ultimately it'll sort of force a lot of people open.
And I think some of the biggest disruptions come when you sort of create these perpendicular intersections of industry and ideas that are best practice somewhere else. And so as we see the friction being reduced in sort of creation and more vision holders getting just closer and closer to the market with fewer layers in between them, I think ultimately what you get is vision holders closer to the market and someone who sits in one industry, the coffee pot industry, able to sort of say, oh, that sleep sensor guy, like I'm gonna kill him because I can get you what you really want when you wake up, which is coffee, right? And you never would have thought coffee guys don't think about sleep; they think about the opposite, right? Typically.
So, what are some of the key sort of design principles as you build all these products? I think, Peter, you have that in your book. I think you came up with 7 different principles. I mean, without going through the 7.
Well,
what's very specific about the concept of developing an Internet of Things product?
Well, what you're talking about specifically, I'm saying if you are designing a device that's supposed to be online, it ends up having 2 personalities. One is the physical thing, meaning the device you can actually physically hold. What are the qualities it needs to have? And that's a design process. But then the other side of it is what does that thing look like from the network down? So from the network down, the physical dimensions don't mean anything. But it does provide services to the network, such as temperature, like the things that you may want to access. And so a lot of the things that we take for granted in our own interactions online, so when we present ourselves online, we present ourselves like I'm 6'2" and I'm a guy. I could present myself as a 4-foot girl online and no one would know the difference. I can present myself differently. And so as a designer, you have all this freedom to do the same thing, right? You can present it in lots of different ways. And so what we found is that even little things like presence, when I first started chatting online, it was with AOL, and so there was that nice little light that went on which said, some of your friends are online or offline, and so that was just a network marker that said somebody's signed in. But then that suddenly became worth more than just are they online or are they not online, because AOL allowed you to say I'm online, but I'm not online for that person, right? So now the presence indicator took on all this new meaning. And so you have to start thinking about when you provide this online sort of personality to your device, what do you want that to look like and how do you want developers to use it? It just opens up a whole set of discussions that are fairly new, and I think that you have to take these into account when you're thinking about devices, because you're taking the network perspective versus just the physical perspective looking up. And it's a different process.
Design principles are going to vary based on application really heavily. I mean, the train wheel scenario that GE talks about, which is phenomenal, and you'll read about it if you haven't already, but is very different. But sort of in the consumer space, so 20% of the applications being built on our platform and devices are non-consumer, just sort of because it's open. But we sort of think of it as easy, intelligent, and open. So easy enough for sort of a regular person, non-soldering irony, person to sort of all of us, including myself, to sort of use. Intelligent, sort of stick the intelligence in the cloud as opposed to in the end device, because it really opens up the scenarios and possibilities. And then sort of this open idea of making it abstracted and open for use by other developers, use by other device makers, and so on. But again, it really varies. Those principles vary based on your target segment and sort of application.
So one of the sort of key obvious questions is privacy and security. So you mentioned the idea of not having, I guess there was an airplane when connected to the public internet, or Alex, you were mentioning all sorts of your wife being surrounded by all sorts of clicking noises in the house. How do you guys think about that as you build products?
Security is usually the first question that people ask about when we start talking about the industrial internet. And doesn't this mean more Stuxnet attacks, airplanes falling out of the sky when hackers get to them? And I think there are a few different points to get into here. One is that everything is connected in some way. And the worst thing you can do security-wise is to have a system that you assume is not connected to the internet. Stuxnet, which destroyed the Iranian centrifuges a couple of years ago, got to the centrifuges across an air gap by spreading through the Iranian nuclear agency's print servers in the office and then onto USB sticks. So the nuclear agency had thought that this was not an internet-connected refining centrifuge, and it was in the end. So it's safer to know that you're online or assume that you're online and then plan for it very carefully. The other thing is that in a lot of industrial applications or sort of heavier, more infrastructural applications, there are a few security techniques that are easier to apply than they are on a personal computer. The processes are highly regular and routinized, and the data is very well defined, and so you can use automated techniques like anomaly detection to watch for things that are going wrong. And then finally, a lot of this connectivity means better safety, if not necessarily better security. If you're driving an automated driverless car, it's probably a better driver than you are. And so on average, everyone is going to have a much safer driving experience, even if occasionally there's a catastrophic, invasion of your car's operating system and you're crashed into a wall or something. It'll be a little hard for the public to get into this at first, but in the way that we all get on airplanes.
Fear of flying versus fear of driving, right?
Yeah, precisely. It's exactly the same thing.
Sorry, keep talking. Maybe that's why we're here, I guess. So any technology has downsides, and in most cases, in this case, there's tremendous upsides that sort of outweigh the downsides. So, but yes, sort of any data from anywhere, right, is going to be the case. I mean, whether you installed the sensor or somebody else did, around you, it's coming. So, we, as an example, sort of take it incredibly seriously. So there's a white paper on the security approach. Our algorithms are open. The sort of most secure systems are sort of open at some level. So a lot of encryption and so on. There's hardware level encryption across the different standards. And then we're building, my background's machine learning, so, building a team that's doing sort of pattern recognition. The Canary, sort of comments really spoke to me. You can sort of look for fraud protection style stuff. Do the patterns not match, in ways that can be very robust. And then we're hiring control theory people, and that is why there'll be central platforms that will emerge. Somebody on Hackaday published how to hack a Belkin Wemo to start a fire a couple months ago. Turn it on and off rapidly, get inside its firmware, and then sort of a switch circuit, bad things happen. So you can, as an example, at a central level, we can build in algorithms that sit above the device or even above the application and look for, this is something that can be turned on and off. Here's the voltage of it. That shouldn't be allowed to happen more than 10 times a second, or X, and you can sit above and watch for that stuff. And it's a very big deal. We have to do a pretty good job, but at the net of it's going to be benefits outweigh the costs. There's going to be all sorts of weird little stories that emerge over the coming years, and as society, it's inevitable anyway. So there you go. Yeah.
Something to look forward to. Yes. So last questions from me, and then I'll open it up to you guys. So maybe for Finn and Steve. How are all these companies going to make money? What are some of the business models? Is there anything specific to Internet of Things companies in terms of business models or ideas?
And my feeling is that you're not going to make money selling things. Yeah. I think that's what I was trying to get at earlier, is that it says the Internet of Things, but what I think the business models have to do with the Internet of Services associated with those things. Take examples like Fitbit and FuelBand and those types. They do sell the thing, but what they're really trying to do is get you to buy other things that have to do with the services associated with it. So you have to keep that in mind because, take it from me, hardware is hard. And it's not going to get any easier. It might get cheaper, but it's still going to be hard to make something which just works and is reliable. We've all been spoiled by the iPhone and how perfect Apple's execution is. So getting that level of expectation from customers is going to be hard. So come up with a device, sell services around it. In my impression, whether it be consumer or enterprise, that's kind of the model that we're seeing going forward.
Yeah, I mean, at least, so what we're seeing is we're seeing a mix. on the consumer side, it's mainly, we're investors in a company called Little Bits and Remotive. Little Bits is essentially, as you know, they're sort of the coming after Bug Labs, which was the what inspired it. But essentially, what we're finding with those companies are very different than some of the enterprise-based companies. We've seen some robotics companies that are now, inspecting the hulls of ships, where that's more of like a service-based model, right? So more on the industrial side, we're definitely seeing more service-based. On the consumer side, it's still TBD. I think we haven't really seen a major consumer hardware from a maker breakout. I mean, Pebble, but I think the jury's still out as to whether that works. But yeah, I can imagine a world though where if we're wearing smart connected devices, that there will be a number of services that pipe into it.
I mean, I get in this conversation a lot with a guy by the name of Eric von Hippel, who's a professor at the Sloan School, and he is of the feeling that if you make a thing, any price advantage you have is temporary because somebody will make it faster and cheaper, usually coming from overseas. And so it doesn't even matter if you have a patent; it'll be knocked off. And so if you're trying to make a device, a thing, and keep a competitive advantage, your price, unless you're like Apple and you have the ability to do R&D at that level, your advantage is going to get small very quickly, especially if you become popular. Like if you start selling a lot of them, someone's going to come in with something just cheaper that does the exact same thing.
And,
so you have to.
And to that point, the company that we've invested in, Remotive, where they're spending a lot of their time, they're innovating on hardware, but all of their innovations in the software,
right,
in the artificial intelligence, because they know that in a year from now, there's going to be 1 million of these things rolling off the line in China. The only thing that's going to separate them from these is the quality of the software and the experience that they're delivering to the consumer.
Right. I agree.
I will say, we obviously think based on our business that it's the cloud and apps and services. I mean, because without saying, that's sort of our model. Even our devices are being published as open hardware now. We want people to build better, faster, cheaper. Supports these open standards, so any way you can get this abstracted data into the cloud, did it move, is fine, right? The cloud just wants to know that and then put it to work. And yet, I think there's an enormous opportunity for the next 5 to 10 years to sort of build new types of connected objects that are differentiated through what you can do with the connected apps and services. And I see like 50 examples a day, right, where this will be the reason somebody goes out and sort of buys a new. You never thought you needed a connected plant feeder, but you're going to buy one, because if you kill plants like my wife and I do, that's suddenly it's problem solved. But there's just you can turn over these existing categories with connected intelligence and make quite a bit on the hardware. Apple demonstrates that still if it's differentiated enough. I think Nest is another good example, and Fitbit, so on. So don't undercount that. There's 5 to 10 years of sort of like a lot of robust opportunities to
totally
create new stuff.
Yeah, I think it's you're trying to avoid commoditization. That's it. And so you're avoiding that on the software side with design and sort of the way you're building network effects potentially, and you're avoiding that on the hardware side again with design and the approach you're taking, or potentially you have some sort of IP around materials or some production method. But I think the assumption that hardware, of course, will be commoditized and software will not. Especially as the building blocks on both sides become sort of bigger and easier to move around by many more people. I think it's hard to assume that there will necessarily be a stark difference.
Great.
I think that just to add one more thing, that we've become very comfortable in the last few years with software provided as a service, and I think one thing that we might see out of the industrial internet is more in the way of machinery provided as a service. With better connections, network connections, and software on cars, it becomes much easier to execute car sharing. It's already very common for airlines to lease the jet engines inside their airplanes separately from the airplanes themselves, and I think we'll see a lot of that model come to sort of smaller scale commercial areas. And if you can create incentive structures where a larger institution, like a bank that leases appliances to you, can somehow capture the incentive to improve energy efficiency or something like that, then I think you'll see a lot of investment in this sort of thing.
Thank you. All right, questions. We're actually starting to run fairly close to the end of the program, but so we'll start with you.
I'm Leonora Bredo Fandino, and I'm self-employed as a software engineer. So New York City is very unique in that we have many industries that are headquartered here with all of the diverse talent that draws. Where in particular do the investors and entrepreneurs see the opportunities in the Internet of Things here in New York?
Everywhere. I can speak as an entrepreneur,
just look
but,
around. I mean, there are thousands of buildings. So, building automation, I think, is one sort of easy opportunity that can be addressed here in New York.
The big buckets, like I said before, I mean, we saw these 2,000 suggestions in one day, and since then the sort of avalanche continued. And, of course, bucket those into 13 major categories and the top 3 and stuff like that. And, of course, security is a great one. 85% of people want some form of security in their life. Most of them don't have it. Why? It's broken ecosystem, model, et cetera. Enormous opportunities there. But energy management, convenience, fun, less worry, on and on and on. And it's not just sort of the categories, but the business models associated with them. I mean, think of insurance as an industry, as a massive industry. The average consumer spends $5,000 a year on home and auto insurance. Insurance is actuarial risk management effectively, and what happens to actuarial risk as data achieves perfection at some level, on and on and on and on. There's this sort of, not just the sort of buckets of applications, but the business models associated with them, new business models that arise, and so that's why I was joking to saying it's everywhere. It's sort of literally it's everywhere, all facets of life as the world comes online, and this medieval stuff like your door that's been the same design since like whenever they had hinges and pieces of wood, suddenly become open to innovation in software. So, big opportunity.
Carter Schoenwald, principal at WellPosed. So, one thing that you guys have all touched on a little bit indirectly at points is about software quality and whatnot there. So, this is sort of more of an observational question on top. To what extent, when you have people starting to play with writing software on top of your tools or platforms, are you seeing that they sort of are realizing that actually being thoughtful about the quality of the software has a very profound physically apparent effect, and does that affect their sort of outlook about how they sort of experiment as they go forward building on your tools or whatnot, or do they still sort of have the random API web app slinging together kind of mentality? Like, is playing with this mix of software and physical world encouraging people to be a little bit more thoughtful in their software engineering? Or, I mean, I don't know, you guys have seen this live or not, so I'd like your thoughts.
So in some categories, yes. So we recommend against sort of smart things for internal defibrillators, at this point, stuff like that. And it really varies by segment. But certainly, when you're sort of life or death situations, people are taking it seriously, and there's lots of opportunities to sort of do a really good job. But there's also an enormous number of sort of playful opportunities, I guess, as sort of the world becomes alive. The chair thing, which. A related example, somebody hacked the Fitbit with our platform a couple weeks ago, so groups of friends can get together and none of their front doors will open if they haven't made their collective step goal in a day. So like if Jim didn't make his steps, my door won't open for me. So it's like a social imperative, and that's, I don't know, is that playful or is it meaningful? It's both, right? And
the one that blew my mind was at the Smart Things Meetup on Thursday, where they actually hacked Minecraft, where you press a lever in Minecraft and object in the real world turned on. And I've been a lifelong gamer myself, and that's like a stupid hack, but it was amazing in that like we're going to live in a world where you can manipulate virtual environments and there's implications on the real world. Yeah. And like take a step back and really think about that. That was done with like a non-serious hack, but it's actually changing the way that we're going to be able to interact with the world.
And I think you've seen the rise of design generally across sort of startups and kind of large internet companies. And one of my assumptions about the driving force there is that your engagement with the internet has become much more sort of personal and intimate based on touchscreens rather than keyboards and mice. So I think you've seen that pattern before, and I think you'll see it again and sort of again and again.
So I use the Matrix example sometimes, and I don't mean it in a negative sense, so maybe it's better to say sort of virtual reality won't be something you plug into. It's sort of more like it's just going to emerge around us, and it's going to be super spooky. It already is. So my wife jokes that I've given her the opportunity to introduce bugs into stuff that never had bugs before. So the light that won't turn off when she wants it to, and other stuff. But it's again, it sort of touches all the facets of life with these behavioral changes. And humans are human. You personify your stuffed animals, starting as a child, and sort of we're playful people. You look at all the stuff that goes viral, and so we'll do really serious stuff with it, and we'll do a ton of ridiculously sort of goofy stuff with it as well. The potential for practical jokes is almost unlimited in this stuff. So,
hey, I was wondering, how do you think the adoption of IPv6 is affecting all this?
The adoption of what?
Of IP of the new regime of IP addresses. Are you able to hack around that, or do you think ultimately the thingification of the internet is going to really require the enhanced address space to be more widely adopted?
I can speak to it a little teeny bit, but
my feeling about IPv6 is that it's right now I think depending on who you talk to, they'll tell you that we're all out of IP addresses as it is, and if you believe now that you're going to have what Cisco says is 20 trillion, 40 quadrillion, whatever the number of devices that are going to be attached to the internet, everyone's going to want to have them to be addressable somehow, and there's a lot of benefits to doing that, right? Just having to deal with just the whole natted, behind a Wi-Fi firewall, getting around that problem would be a huge benefit for using IPv6. So I think it's coming. I think the problem is just going to be who's going to actually make it happen. I think there's a huge, the standard's out there. Now we've got to get all of the intermediaries to adopt it. I'm not an expert on where that is, but I think from the standpoint of innovation, I think it's going to happen. I think it'd be great to happen.
So we see it percolating at the individual connected thing level, where Zigbee is an example, or any of these standards just sort of adopting it gradually. But it's also sort of lessened by this hub and spoke and mesh model. So we can address that this is this sensor that's got its unique hardware identifier connected through this specific location to this specific account, and you can sort of create an address space that isn't. It's not like every raw device is necessarily on its own as a separate IP address on the internet. There's identifiers based on how they're organized that you can sort of cope with now. So we don't see a shortage of ways to identify things to make it work at the moment.
I also had a question about software quality. What?
Name and company.
Oh, Roman at PlaceIQ. So there's a lot of buggy and crappy software out there. So what happens when that software starts controlling cars and electrical devices? What are the implications for consumer safety and regulation?
That's a great question, but if web services companies have gotten very good over the last few years at building nuanced APIs that let you do some things and not let you do other things. I think the Internet of Things is just going to expand on that. These APIs are very secure. They're very good at letting you, give Zynga access to your friends list, but not, the important things that you care about on Facebook because Zynga is, maybe you don't trust it. In the same way, we'll see a lot of that in the Internet of Things. Good nuanced permission systems so that you let this app turn up the volume in your car radio, which is a pretty harmless thing to do, but you don't let it turn off your power steering or something. Only a much more trusted app can do that. So.
That's exactly right. And it also provides layers of modes or patterns of information. So if I'm present, let an app do X, and if I'm not present, then don't let it do other stuff, and on and on and on, stuff like that.
So you also put your finger on the argument between closed and open systems. So I was sitting down with Randy Commissar, who's one of the investors in Nest, and Tony Fidel. That's a totally closed system right now, and the reason that they did that is because they said we need to 100% own the customer experience so that stuff like that doesn't happen. So if somebody calls up and says, my Nest isn't working, they need to know exactly why. They've done the hardware, the software, the entire integration. They know exactly what the problem is. And if you're a closed system, if you own the whole stack, you can do that sort of thing. So Apple has the app certification process. So the whole goal is to not allow crapware to get out there. Of course, there's lots of it out there. But the point being that in a closed system, one of the arguments is you have a lot more control over exactly how that stuff happens. Open, there are safeguards with respect to APIs and so on, but it's a little bit of there's a sacrifice in both directions.
Great. I think we have time for one last one. How do you think about, and I know
I know on the industry side of things, Rob Rakowski, Ruth Asset Advisors, thanks. On the industrial firms, GE and Westinghouse and whatever, they've all thought through what if I don't have a connection and what if somebody wants to connect into my engine. But on the consumer side, what if we need bandwidth as a service? How do we cache bandwidth in the sense that the application that we write goes awry, and all of a sudden that light is on or my faucet's turned on and it's running and there's no way to turn it off? How are guys thinking about, I don't have a connection back to the internet. I don't have a way to get back and fix whatever I did, and I need to cache some either capability or some bandwidth.
So you're asking what happens when
How do you think about
when a network connection is lost or something? What happens when they go offline?
Forever lost.
Yeah, that's sort of, I think, at the heart of Cisco's argument these days when they talk about the Internet of Everything. Is it's this like broad continuum of intelligence. It's not just that everything is going to live on the cloud or that everything is going to be a cheap embedded system. It's that someone there informally called it fog computing, which I think I wasn't supposed to repeat because I don't like it somehow, but I think it's an awesome way of thinking about it. Instead of just on the ground or just in the cloud, it's like this continuous sort of fog of computing, of intelligence everywhere. So you have some intelligence locally, some intelligence in the middle, some intelligence at the level of the cloud. And especially in really crucial applications, more intelligence resides at the level of the machine and doesn't depend on the network connections.
So a brief comment on that. So this is clearly an implication for us right now. So just a tactical example of exactly that is, so we've created a technology we call wiring internally. It's actually one of our patent claims, but it's a lot of thought to how you create an abstracted app in the cloud, but that the hub, it knows what portions can be executed locally, and so it will push those down to the hub level, and then they will continue to operate locally, even absent the cloud for some period of time in a sort of elegantly degraded state. Obviously, if there's a severe weather alert and your window's open, that sort of app, you needs to know if there's a severe weather alert, it sort of needs there to be internet connectivity. But a lot you can do locally, a lot of the sort of simple, localized control and so on. So there's already effort to sort of make that happen, still let you be a developer and have this abstraction sense, but press it down locally wherever you can. And then, of course, the sort of long-term threat is, the internet, the trend is your friend. Like, there will be connectivity sort of more and more reliably everywhere, but the practical reality today in these early stages, you have to deal with the, fluttering of connectivity, I guess is what I'd call it.
Okay, great. So, I'm sorry, one last.
It's a big issue in designing drones that usually maybe depend on a data connection to the national airspace air traffic control system, but when you lose that, as you often do, making sure that there's enough computer vision, sort of ability to avoid obstacles and collisions and so forth, and fly the plane safely until you get another connection. So there are a lot of people working on that in really robust ways.
Okay, very cool. Let's wrap up. So if you have more questions, all those guys are going to be around for a little while longer. Dash, Placemeter, and Canary are going to be here as well, so don't hesitate to come and talk to them. And now my favorite part of the evening, let's go drink. Thank you very much for a wonderful event. Thank you.